Welcome. Let's solve Leetcode 1014 best sightseeing pair. Okay, so let's make this bigger, sorry. You're given an integer array values where values I represents the value of the ith sightseeing spot. Two sightseeing spots I and j have a distance j minus I between them. The score of a pair of sightseeing spots is the values at I plus the values at j plus I minus j. The sum of the values of the sightseeing spots minus the distance between them. Return the maximum score of pair of sightseeing spots. Okay, seems easy enough. So in this first problem or example, the answer is 11, and because they consider, so if we use this first value 8 and the second value 5. So remember, the way we calculate the sightseeing spots is, or the score for the sightseeing spots is to add the values and then minus the distance between them. So 8 plus 5 is 13, and the distance between them is 2, so 13 minus 2 is 11. So this is somewhat straightforward. In this problem, there isn't much to do because it's too simple, but in order just to follow through with it and get an answer, the two values add up to 1 plus 2 is 3, and the distance between them is 1, so 3 minus 2 is 1. Sorry, 3 minus 1 is 2. One note of importance here that I found was I think that you're guaranteed to always have two values in the values array. So we'll be using that for the approach I have in mind. Okay, let's get started. I think it's straightforward. Okay, let's move this off to the side a little bit. Okay, so what we're going to do is we're going to use somewhat as a running total type of idea. Okay, so let's figure this out. So we'll do something like we'll store the best left score, and we'll store the best best score overall, and we'll use maybe a current left, and that should be it. We'll keep a running value for the right. So remember, well, let's just go through with it. So what we'll do is we'll initialize best left and best score. So let's see what they are. So remember, I told you earlier that we know for sure that we have at least two values. So as of now, what we'll do is we'll say, okay, the best left will equal 8. Well, why is it 8? Remember, so the way the left value is created is, remember, we use the values I, and then we use the index at I. So at values I currently is 8, and the index here is 0, so 8 plus 0 is 8. That's the best left score so far. And as of now, the best score is just 0 because there is no right score. So then let's loop through the values starting at index 1. Okay, so we'll do that. Okay, so then we'll say something like for I in range, I guess 1 to length of values. Length of values. Okay, so then we'll say, okay, what's the current right? So the current right will be what? So how is the right value calculated? So we use the value at j. Okay, so no problem. We can do that. Values at well, in this case it's I. But then notice how it's slightly different. We use the values at j, but then we subtract the index at j. So then we say, okay, minus I. Okay, great. So now we have the current right, and we have the best left. The best left, remember, will always is the biggest value. And so our overall goal, our overall goal is to maximize what? We want to maximize this here. We want to maximize that. So we want to maximize this, which is essentially this here. I'm going to adjust how this looks. So in essence, we want to maximize this. So this would be our best left, and over here would be our best right. Sorry, let's do something like this. Yeah. So we want to maximize this. So the left's value, or the best left, will be stationary, meaning like we want to, it can be stationary. So for example, like if we're looking at this 8 here, this is a really good score because it's 8 and it's a high value and the index is low. But as we move farther and farther to the right, it's not so good anymore, because remember, as we move farther to the right, they subtract this distance here minus the distance between them. So we'll always have to keep that in mind. In any case, the current best left is this values plus I, and the same thing in the right is going to be values of j minus the index. So we'll have to keep that in mind. So in any case, the current right is this here. So let's calculate it. So we'll say, okay, but in particular it's this. The current right would be, remember the current right would be, so it would be 1, because we're at 1 here, we're starting at 1, minus the index, which is 1. So this is actually 0. But so then we ask ourselves, is the best left plus the current right, is that better than the best score? And if it is, we'll update it. If it is, we'll update score. Update best score, if it is. Well, let's check. So in this particular case, the current right is 0. The best left is 8. Is 8 bigger than the best score? The best score is 0. So in this case, yes, it is. So we would update it. So in this case, we would update it. So let's change this to, well, let's change it to 8. And that should make sense, right? Because remember, according to this formula here, they add the values. 8 plus 1 is 9. And then they subtract the distance. And the distance is 1. So 9 minus 1 is 8. So that's what we have. Okay, great. So now we've updated our best score. But now, since we've moved another value, so remember, we started here, but it's possible that our best left can be maybe this one now. So we need to check that. So let's check. So the current left, so I know we didn't have that before because it makes sense to have a left score, but now it does. So the left score can be either of these two. So the current left will be, we'll update it. It'll be the values at I. Now remember that the left score is going to be plus I, which is different from the current right. So remember, at the right, you're always subtracting the index. At left, you're always adding the index. So the current left is going to be this. And then we'll ask ourselves, is this a better left? So if current left is bigger than the best left. If so, we'll update left, update best left. But in this case, let's check it out. The current left would be, it would be 1, but plus 1 because it's at index. So it'll be 2. Is that greater than best left, which would be which is 8? And so the answer is no. so it wouldn't get updated. Okay, let's try another one then. Let's move on. So now we'll be at index, or here we'll be at 5. So let's update this here. So let's maybe erase this. So values I would be 5. 5 minus the index, which is 0, 1, 2. So minus 2, so this would be 3. And then we'll say, okay, is the best left plus the current right better than the best score? So the best left right now is still 8. So is 8 plus 3 bigger than the best score? Well, yes, it is. So then we update best score, so that which is going to be that. So now this becomes 11. Okay, great. Then we update our current left. The current left would be values I. So values I would be 5 plus I, which would be 1. So it'd be 6. This is 6. Okay. And then we check, is the current left better than the best left? The best left right now still is 8, so we don't update it. So we don't need, it would be 6, and that's not true, so we don't need to update left. And then we just keep on doing this more until we're on and on until we have looped through the entire array. Okay, I think that's enough to get started, so let's do it. Okay, so let's do it. What do we need? We need to initialize our best left, and our best score. So we'll set the best left equal to values at 0, and the best score is 0. We don't know it. And then we'll start looping from the first value. So for I in range 1 to length of values. So we've used the first value, so we need to start from the, this is our left now, this is going to be our right. In a way I can just probably, yeah, that's fine, I. Remember, we can do this again because we have 2 values guaranteed to be in our values list. Okay, so let's get started. So let's calculate our current right. So the current right will equal values at I, but we subtract the index. That's how we do it for the right one. We subtract the index. And now we can, at this point, we can form a sightseeing pair. So let's form a sightseeing pair and see if that's better than our current best score. So if the best left plus current right is bigger than the best score, then we update it. Best score equals best left plus current right. Typing is not that good today. And then, okay, so now we've updated our best score if necessary. And then we check, okay, let's update our current left. So current left, the current left will be that value at the current index, so values I plus I. Remember, each side, left and right, has a different formula for constructing them. So I think I showed this before. And the values I is going to be the value plus the index, and values the right endpoint, or the right side of the sightseeing pair will be that value minus the index. So at this point we're updating our best left part of the sightseeing pair. So we're going to check if this current left is better than the best left. So if current left is better than best left, then we update it. Okay, and that's basically it. And then we just return our best score. Okay, let's check it locally. I will show you something that I find interesting after we run this. Okay, so it looks really good. So again, I just want to show you something now. You can probably stop watching if you'd like. But I want to show you, this code doesn't look very clean, and I want to show you if we can maybe consolidate it and use the max function. So let's go over that. So let's see if I can rewrite this so it's a little bit more, I guess, pretty, just to say it easily. Okay, so we want to maybe update our best score. So let's say, let me see. So max of best score, and we use best score here. Best score equals max of best score. And what are we comparing it to? We're comparing it to best left and what? The current right. Well, the current right is this thing here. This value is I minus I. So let's move that over here. Let's just put that over here. And okay, so let's take this off. We don't need this anymore. And we don't need this check anymore because that now it's taken care of here. Now let's just check it locally, just to make sure it's still running correctly. Okay, good. I'm actually gonna run it. I'm gonna submit it again. Now you'll see it's a little bit slower just because I changed this. Okay, now let's check this out. Can we make this more cleaner or Pythonic? Let's check. Okay, so what's happening here? Maybe, so we want to check if current left can be updated. So current left equals max of current left. What are we comparing it to? We're comparing it to the best left, which is this values plus I. So let's move this over there. Okay, and so now we don't need this anymore. Let's run it locally, see if that works. Sorry. Current left. Sorry, that was entirely wrong. What we're checking is we want to update best left. So yeah, so let's change that. This should be best left. My apologies. And then how are we comparing best left? We're comparing it to this guy here. Yeah, that was a blunder on my part. Apologize. All right, let's try it again. Okay, looks like it's good. And now let's submit it. So notice how it's terribly slower. So I often ask myself, like, why is it slower? Like, it looks prettier, but for me, it's a little bit more difficult to understand it. But that's not really the reason why it's slower. The reason why it's slower is because, remember, for this problem, they tell us that we can have what the length of this array is, what is this, 10,000? So 5,000, 50,000, 50,000. So you're running a function, you're running a max 50,000 times, and then another max, another 50,000 times. So you're running possibly 100,000 times. But remember our previous solution, it didn't use any functions. It was a simple like if-else statement. Remember I just had it just had an if this, do that. Yeah, and if we check if the best score can be updated and if the left can be updated. And that was it. We didn't use any function calls. So if you can avoid function calls, then and you're looking for performance, then if you can, remove them. In my opinion, the other approach was more readable, and it was a little bit, well, and it was clearly faster in terms of time complexity. So I preferred the other version, but I must admit this is much prettier, and it is much prettier. But as far as like other people coming in and looking at it and having an understanding of what's going on, it's not so as obvious as the previous approach. Okay, this is just I just wanted to point this out to you, and if you use it or agree with it, it's fine. But in any case, if you found this in any way helpful or beneficial, please consider liking or subscribing. Other than that, have a wonderful day and take care of yourself.